So I'm here in a studio with this great green screen, but I've only got half an hour left in my book time to tell you about Meteor Lake. Now, I recently spent time in Malaysia with Intel on the Intel Tech Tour Malaysia. We were in Penang and Kulim, where we saw a large number of facilities for packaging and testing and all that good stuff. I've got a video with the guys over at PC World. Me and Mark Hackman went through everything that we saw on that trip. I highly suggest you check it out. But as part of that trip, we also had Meteor Lake Tech Day. And obviously, that's a really important part of what's going to be Intel's next generation product. Now, as this video is going live, the embargo on all the information that we got that day has lifted. Now, I'm going to tell you everything that I can in the short time I still have left in the studio. If this video is only 10 minutes, then I kind of screwed up a lot, but we'll see. So Meteor Lake. For those of you who are unaware, Meteor Lake is Intel's next generation chip. It's going to be involving tiles. We've got chiplets involved here. It's a whole bunch of new technologies all coming together, and it's essentially the start of the new era of Intel, not only in the way that products are designed, but also in naming, and that's going to come up quite a bit in the discussions of this chip when it comes live. Now, I should clarify that the tech day that we had wasn't end product focused. So we didn't get any SKU lists, we didn't get any frequencies, we didn't get any performance numbers explicitly. However, we did go into the design, a little bit into the architecture, and then speaking about all the new sort of manufacturing technologies that they're using inside Meteor Lake, which is going to be a key important part of Intel in the future. So let's go over that. For me, as a person who's really interested in the physical design of this technology, but also the microarchitecture, let's start off with what Meteor Lake looks like. Now, Meteor Lake, according to Intel, has 4 tiles. Technically, it has 5. What do I mean by tile? Tile, or a chiplet, is essentially a little piece of silicon that you connect together with a high-speed bandwidth link to another piece of silicon, usually in some high-performance design, whether that's with an embedded bridge or an interposer, or direct die-on-die stacking. What Meteor Lake is doing here is that they have 4 tiles that hold logic. Logic and I/O, that's the sort of bit that does all the heavy compute and what have you. And a base tile, which is kind of like an interposer. And the tiles are connected together through a packaging technology called Foveros. Now, Foveros is Intel's die-on-die, essentially 3D stacking technology with 36 micron, or actually I think this is 45 micron, they're going to 36 micron in the future, microbumps. This is designed for high-speed connectivity and low power. They're saying 0.3 picojoules per bit, which is extremely low for die-to-die interconnect. And that base tile is built on what Intel calls its P1227 process. It doesn't have an official name like Intel 4, Intel 7, because realistically it's perhaps about 1,000 nanometers or multiple microns in size. The point is the base die doesn't have to be that precise as the other dies. Of the 4 tiles that are on top, and we'll show an image of this, you have the CPU tile, you have the GPU tile, you have the I/O tile, and you have the SoC tile. So let's go through them all. CPU tile, as it suggests, holds all the CPU cores. This is built on Intel 4, or Intel 4 nanometer, however you want to call it. Why is that important? This is Intel's first production of EUV-based chips. TSMC has had multiple generations of EUV from N7P, I think it was, then N6, N5, N4, and now N3. So the fact that this is Intel's first EUV product that's actually widely commercialized and essentially as in volume ramp, they've done a couple of demo test chips that haven't been widely distributed, but this is the first implementation of Intel's EUV. So they're getting the benefits of using EUV technology, decreased layers, and hopefully some increased performance as well. But on this die, you have 6 performance cores, and let me get it right here. These are Redwood Cove cores, which is a minor update on the previous generation. They're not saying it's a performance update. They're saying it's a power efficiency update. So we'll get into that. And then they'll also have 8 efficient cores, 8 E-cores, and these are Crestmont cores. These are an update over the previous E-cores with about a 6% IPC improvement, they said. So what you essentially have is this chip will come in one version, and it's what we call a 6P with 8 E-cores, 6 plus 8. So people used to desktop chips being, sort of 8 plus 8 or 8 plus 16. This is very much a mobile chip, and we'll get into that in a bit. After the CPU tile, you have the GPU tile. The GPU tile is built on TSMC N6, I believe. Let me just double check this. The GPU is on TSMC N5, correction. TSMC N5, and this is still Alchemist, but it's like a bigger Alchemist. It's almost A380 size in terms of compute, but it's running off DDR memory, or LPDDR memory, so you have to factor that in. They're saying up to 2x performance compared to previous gen on the GPU. Okay, so on the GPU, we're giving the GPU presentation from Thomas Peterson, also known as TAP, the ex-NVIDIA guy who shows up a lot on streams. He's saying that the graphics on Meteor Lake are twice the performance to previous gen and 2x performance per watt. That's pretty impressive. And what they're doing is they're taking a lot of work that they've done on the ARC software stack on the discrete cards, and that's now coming into mobile to make that all efficient. So all the recent driver updates that you've seen for the ARC discrete cards, that's all coming now to mobile. In terms of the media engine, we've got AV1 support, as you might expect from the big ARC cards, including film grain. We're talking 8K 60 HDR encode or decode, and then 8K 10-bit encode. There's a multi-function codecs in fixed function between video scalers, color space enhancers, tone mappers. Media engine is large. Actually, the Media engine is not even on the GPU tile. The GPU tile is just GPU. So actually, what I should say is, so we're used to GPU being either LP for low power on the mobile chips, or HPG for high performance gaming on the big ARC. What Intel have decided to do is essentially smush them together, and now we have LPG. So low power gaming. Did I say low performance earlier? I meant to say low power, sorry. The whole point is that it's an efficiency designed GPU, and they're trying to bring everything that they've learned from ARC into the mobile space. So that means support for DirectX 12 Ultimate. It's going to have hardware ray tracing. It's going to support XeSS. One interesting thing here is that it's going to have massively higher clock speeds, and there's a graph I'll show up whereby, as part of using the more efficient manufacturing process in this design and some of the power delivery metrics or adjustments that they've done, they're able to run this at 0.72 volts at about another gigahertz higher than in previous designs. I think the graph showed essentially up to 2.4 gigahertz. So 2 times frequency at the same voltage at 0.72 volts. So going from 1 gigahertz to 2 gigahertz. And on top of that, in terms of machine learning, they're saying that on the GPU you have a 20% power reduction. We can have 8 Xe-cores, 128 vector engines, which is 33% more, double the geopipes, 33% more samplers, more pixel backends, and obviously 8 ray tracing units, which is new. Each Xe-core will have 192 kilobytes of L1 cache or shared local memory, which is similar to the high performance graphics. And then we have the vector engine, which is SIMD, can do all the floating point 64-bit. But there's also going to be extended math in here. They're doing some slight variation. I'll show a picture of how the architecture is changing as well. And then, we also have the HPC inherited features like DirectX 12, double rate, high Z culling, asynchronous copies, and out of order sampling. They did show some synthetic tests versus Raptor Lake. Now, these synthetic tests in GPU land can be a bit misleading, but they're useful for understanding fundamental architecture. Depth test rate 6.6x, pixel blend rate over 2x, triangle draw rate over 2x. In terms of ray tracing, they're showcasing hardware ray tracing in Blender versus CPU only. And in the classroom Blender test, if you're familiar with it, it's 2.6x. And yet bringing all the software from ARC down into mobile now. That's driver optimization in DX9, but also reducing power. They're saying that they can do XeSS in the order of about 500 millijoules per frame rather than 800 millijoules per frame, which is an interesting way of saying things. They also have a new feature. They're also going to have a new feature in Intel Arc Control, where they have it's kind of like a frame rate limiting feature with maximum battery at 30 FPS, balanced at 45 FPS, and then relaxed at 60 FPS, depending on obviously your chassis and how it's support. The interesting metric they pulled out here is that when you're on the max battery setting at 30 FPS, they didn't say what resolution, but they did say you can run Rocket League with 1 watt of power. That's quite impressive. So that's the GPU tile. Then the next biggest tile is the I/O tile. This is on TSMC N6. This is on N6. And this has all the fun stuff. The one particular thing that I think people should take home is that this tile has 2 low-powered E-cores. So we've had P-cores and E-cores in the CPU tile. Now we have low-powered E-cores in the I/O tile. So remember before when I said this was a 6 plus 8 design? This is actually a 6 plus 8 plus 2. Now Intel has 3 levels of performance in Meteor Lake. What these 2 low-power E-cores are going to do is essentially offer on TSMC N6 rather than Intel N4 or Intel 4 workloads that are going to run in the background that aren't needed are going to essentially only run on those low-powered E-cores. And assuming you're not doing anything like my laptop is doing now, maybe it's running a little background task or anything, it doesn't need to fire up the big CPU tile. It doesn't need to waste all that power, it doesn't need to waste all that latency. And as a result, the point is more efficient, especially for battery life, especially in instances where nothing is running. Imagine you're typing on a Word document. It's saving power in between the key presses. It's saving power when you're watching video and stuff's just running in the background. Along with this, there's going to be a change to Thread Director. Thread Director before put every workload on a P-core, and then between the chip and the OS made the final decision, but the chip gave hints whether that workload is going to go down to the E-cores. This time around, all workloads will start on the low power E-cores and be promoted if the OS deems the thread worthy. And obviously that's going to rely on chip suggestions that essentially analyze the workload through heuristics and then say to the OS, this thread should be increased in performance. They didn't talk about the latency in which that happens. I suspect it adds a little bit of latency, though I fully expect it to be the latency within a single frame. So people are unlikely going to notice it. It's going to be something that we're definitely going to have to watch out for because it's going to change how everything works. So I'm glad that low-powered E-cores are in. I desperately always want more battery life. And if it means they don't need to fire stuff up, excellent. In the I/O tile, we also have the memory controller. We've got DDR5 and LPDDR5 this time. When asked if it supports DDR4, the answer we got was it supports DDR5. So I don't think it's going to support DDR4 or LPDDR4 this time around. Means there might be a little cost adder, but it's going to be worth it. I should say that this is dual channel, mobile dual channel DDR5. In some of the slides that Intel showed us, it said that graphics is only going to be available in dual channel memory configurations. So there may be versions of this chip that don't have the integrated graphics and are only going to be single channel. Beware of those. I think single channel, even if you have a discrete graphics solution, is going to hamper that slightly. So it's more of a comment more about Intel's Meteor Lake yielding, I think, than anything else, but we'll have to see. Also in the I/O tile, we have the media engines. So rather than have the media engines in the GPU tile, which you may assume, hang on, it's GPU stuff, it's graphics. By having them in the I/O tile, it means that you can run video without waking up your GPU. Again, speaking to the low power nature of everything. So this is where you have your AV1 encode decode. You have 8K HDR support. All that fun stuff that's going to come inside that. Let me find my notes here. So you've got the media engine, which is your multifunctional codec, your video enhancer, tone mapper, display engine. So there's going to be 4 display pipes, so you can get 4 displays out. 2 of them are optimized for low power. they say they're optimized for end-to-end unified compression and low power modes for media playback. One of the interesting thing here is frame decode. So normally what you think of how a video is being played back, the media engine takes a frame, decodes it, puts it to the buffer, decodes a frame, puts it to the buffer. And depending on how long that frame takes to decode, it has to wait, but it either has to wait in a high power mode or a low power mode. Do you have enough time to go down to a low power mode? Do you need to keep the memory where that video is coming from, the DRAM? Do you have to keep that controller powered on? What Meteor Lake is now going to do is, rather than it doing it frame by frame by frame, or doing some minor optimizations, it can support decoding 16 frames at a time. Now, if you're watching 24 FPS content, that means that it's going to pull essentially once every 2/3 of a second data to decode and then go to sleep. And then obviously the display engine is going to showcase your data on your display, and then it's going to pull another 16 frames from memory and then go back to sleep. That is going to save power. The idea is that saves power in the long run because you're not going in and out of sleep modes. Why 16? I guess that's just a very nice number for now. That may increase in the future. We'll have to see. It says decode up to 16 frames at once and send the ones to display so cores and other stuff isn't turned on. The media engines can present timestamps, and this is a new thing to Windows, so it can get frames early and do hardware flips and stuff like that. The display engine also supports HDMI 2.1, DisplayPort 2.1, 20 gig, and eDisplayPort 1.4, adaptive sync over HDMI, and you can power 4 4K 60 HDR screens on this, according to my notes, which sounds very good. Now, also on the I/O tile, we've got to speak AI, machine learning. If you may or may not know, Intel acquired a company a while back called Movidius. Movidius made a product called the VPU, the Video Processing Unit, and they were essentially meant to be the potential big players in video processing at the time, sort of like a precursor to machine learning. And then machine learning came out, and everything went head over backwards and everything else. What Intel are doing with Meteor Lake is including an NPU, a neural processing engine based on the Movidius architecture. Technically, version 2.7 for those of you who are very familiar with this stuff. But what this means is that Intel is pushing machine learning support in hardware, just so stuff that is machine learning based, especially inference, for example, blurring backgrounds or gaze tracking, that's going to be enabled through the onboard NPU, mostly through the OpenVINO package. Is it part of one API now? I'm not sure. But Intel's been offering this OpenVINO package for a while. Software developers who have used it will be very familiar with it. Now it comes built in. To the chip. And I actually just recorded a video on Thunderbolt 5, and I said one of the big reasons why Thunderbolt 4 took off the way it did is because Intel started shipping every chip with a Thunderbolt 4 engine. Now with Meteor Lake, every chip gets an NPU. So that is going to offer the opportunity to increase machine learning use cases on the device rather than the high latency, perhaps, of the cloud. We're going to have to wait and see. They did go into a deeper dive with all the features of the NPU. For example, it's technically a dual-core NPU with what looks like systolic arrays, but it's got a programmable DSP. It does have a MAC array that supports matrix multiply and convolution. It's much more than a systolic array, according to my notes, just because each matrix multiplying it just does a lot more. Has activation functions for machine learning, if you know what ReLUs are, and supports pipeline support. It also does on-the-fly data conversion for quantization. The DSPs are VLIW, that support 8 instructions. And technically it supports everything from int4 through to FP32, depending on your network. And realistically, people are going to say, well, who's in the lead in terms of onboard mobile NPUs? Is it going to be Intel with this NPU, or is it going to be AMD with the AI engine? Right now, it's probably going to be Intel, just because Intel's already had the software support out for it. They've been going at this early, even though AMD was to market first. they're working with explicit partners specifically for specific workloads. The whole idea of the NPU is it's going to be open to everyone. I remember last year I was seeing some demos with this because they've technically had this hardware out in M.2 form factors for industrial use cases already. I've seen stuff where you can add it into OBS for streaming. Streamers can get to it. This NPU is exciting enough that I've been telling the group to put it on an M.2 card for retail, and there seems to be some traction with that. I hope it gets more traction, but we're going to see a lot more use of machine learning and AI on laptop processors from now on. There's probably a bunch of other stuff in the I/O tile that I've not spoken about. Things like security, that's all going to be managed there. Probably do a whole video on security. I've already mentioned the memory controller. There's technically a NOC fabric. Oh, I guess one thing I should mention about the I/O tile before we leave it is that there is a new power delivery management system in play. The fact that you have multiple tiles means that you now have to deal with how your power is performed. So there is a centralized power control, and then each tile has its own sort of like microcontroller with a relationship to power and how power is distributed. So it's a more of a feedback generated system than it was before. So power can go where it needs to go, in combination with the Foveros on the tiles and everything else. That's the I/O tile. There's also the SoC tile. The SoC tile is a little one in the corner in the diagram. That essentially has PCIe and Thunderbolt. They didn't necessarily say how many lanes of PCIe are going to be involved in this. There is going to be some PCIe 5, it sounds like. And then Thunderbolt 4. I think they said Thunderbolt 4, and doubly certain they said Thunderbolt 4. And in terms of Meteor Lake, that's probably about it. The I/O tile is TSMC N6, I should add. Questions I asked. So in terms of bandwidth, the bandwidth inside the chip is geared to equal the bandwidth outside the chip. That way there's no excess power wasted, and it's all in sync. There is that. I asked if you could disable the E-cores and LPE-cores on boot because I want to do fancy stuff, or disable all the P-cores so I just have E-cores. They say no, that's still you still need at least one P-core running if you want to disable it, but I'm the only idiot who would think to do that. I guess I should speak a little bit about the testing because I was in town to look at their testing facility. One of the issues when you do tiles in this format, not like AMD's tiles that are differentiated in package. When you have chips on top of chips and they're integrated, and power management comes through, and you have some sort of power delivery between the chips, it becomes very hard to test them in isolation. And the thing is, when you manufacture chips and you get chips in, whether it's from Intel Foundry or from TSMC, you need to know whether those chips work before you connect them together. This is a concept of known good die. And what Intel has done here is something that I think a lot of the rest of the industry is struggling with, is how do you test silicon that you've created, tiles or chiplets, that require the use of other tiles and chiplets to even work in the first place. So this is what Intel calls singulated die test. So what they've been able to do is develop an ecosystem internally such that they can test individual silicon dies before they get put together. That way you can get all of your silicon. You can have known high performance CPU die, known high performance GPU die, known good I/O tile, known good SoC tile, put them together and hopefully get better binning on the endpoint of your chip. That means better frequency at the end and a better end product for customers to use. We're still expecting Meteor Lake to come out by the end of the year. Like I said, right now it's just more of sort of an architectural deep dive. I didn't necessarily go into the details of Redwood Cove and Crestmont. Perhaps we can do a separate video on that explicitly. But I'm looking forward to it just because I've been burned so much with mobile processors in the past. I really want something to work. I've also not really been an advocate for hybrid design. I think this may be a push in the right direction. It also helps that they're making noises that the video editor I use to edit these videos is actually going to end up being Intel accelerated in some way, whether that's machine learning or GPU. I don't know yet, but I am asking questions. So we'll have to see. I want to go pick up a Meteor Lake laptop and also, test out Intel 4. Intel 4 is a big question mark here. And I think it's going to govern how well Intel 4 and EUV-based products are going to end up down the line. That's Intel 4, Intel 3, the enterprise stuff, whatever. So that's my very quick, and I noticed that I am running very close to time here in the studio on Meteor Lake. If you have any questions, please put them down below. May end up doing like a separate Q&A stream to cover those. But yeah, it's impressive stuff, and competition is good. Competition is good.